Right now, there's a technological war happening that'll determine the future of artificial intelligence, cloud computing, and potentially hundreds of billions of dollars in market value. This is the AI chip wars, and it's heating up like never before. NVIDIA has dominated this space with over 90% market share, but the competition is finally catching up. AMD, Intel, Google, Amazon, Microsoft, they're all throwing everything they've got at this battle. And the stakes? Control over the infrastructure that powers every AI model you interact with. Today, we're breaking down the entire AI chip landscape, who's winning, who's losing, and what it means for investors. Let's dive in. Before we get into the battle, let's understand what we're actually talking about. What makes an AI chip different from a regular computer chip? Traditional CPUs, the processors in your laptop, are designed for sequential processing. They handle one task at a time, really fast. But AI doesn't work that way. Training an AI model requires thousands, sometimes millions of calculations happening simultaneously. That's where AI chips come in. We're talking about GPUs, graphics processing units, originally designed for gaming but perfect for AI. Then there are TPUs, tensor processing units, custom-built by Google specifically for machine learning. And ASICs, application-specific integrated circuits, chips designed for one specific task and nothing else. These specialized processors aren't just a little faster than CPUs for AI workloads. They're tens to thousands times faster and way more cost-effective. They achieve this through massive parallelism, running thousands of calculations at once. They use lower precision math. Instead of 32-bit calculations, they use 8-bit or even 4-bit, which is faster and uses less power. And they're optimized for memory access, keeping entire AI algorithms on a single chip. Bottom line, if you want to train the next ChatGPT or run AI at scale, you need these chips. And that's why this market is worth fighting for. Let's talk about the elephant in the room. NVIDIA. They control over 90% of the AI accelerator market, and in some estimates, it's closer to 95%. How did they get here? It started with the H100, NVIDIA's workhorse chip that powered the first wave of large language models. Companies were paying tens of thousands of dollars per chip, and they couldn't get enough of them. Then came the H200, twice as fast for large language models, with 141 gigabytes of memory and 4.8 terabytes per second bandwidth. Massive upgrade. But the real game changer? The B200, also called Blackwell. Launched in 2024, this chip is revolutionary. We're talking 208 billion transistors, a dual-chip design, 192 gigabytes of ultra-fast HBM3E memory, that's 2.4 times more than the H100. It delivers 8 terabytes per second bandwidth and up to 20 petaflops of performance. In real-world benchmarks, the B200 delivers 3 times faster training and up to 15 times faster inference compared to the H100. Inference is when you're actually running the AI model, like when you ask ChatGPT a question. NVIDIA's software ecosystem is another huge advantage. Their CUDA platform has been the standard for years, which means developers already know how to use it. Switching away from NVIDIA isn't just about buying a different chip. It's about rewriting code, retraining teams, and taking on risk. But here's the thing. Dominance breeds competition, and the competition is coming hard. This is where it gets interesting. NVIDIA's competitors aren't sitting still. They're attacking from every angle. AMD has been NVIDIA's biggest rival in GPUs for years, and they're finally making serious moves in AI. AMD is leveraging its success with Ryzen CPUs and EPYC server chips, and now they're releasing GPUs specifically designed for both AI training and inference. Their strategy? Aggressive pricing and competitive performance. They're undercutting NVIDIA on price while delivering solid performance. Intel just released Gaudi 3, and the numbers are impressive. Intel claims Gaudi 3 runs AI models 1.5 times faster and more efficiently than NVIDIA's H100, with competitive pricing that emphasizes power efficiency. Intel is also investing billions in manufacturing capacity to become a foundry, not just making their own chips, but manufacturing for others too. Now let's talk about the cloud giants building their own chips. Google has been ahead of this trend for years with their TPUs, tensor processing units. But now they've expanded with the Axion CPU for data centers, which delivers 30% better performance than ARM-based chips. Their new Ironwood TPU focuses on cost-sensitive inference tasks. And here's the kicker. In October 2025, Anthropic, the company behind Claude AI, announced plans to access up to 1 million TPUs from Google Cloud in 2026. That's a massive vote of confidence. Amazon Web Services has Trainium and Inferentia chips. Their Trainium 2 delivers 30 to 40% better price performance than H100-based instances. The cost per token for training is 50 to 70% lower than NVIDIA H100 clusters. The catch? Developers need to learn AWS's Neuron SDK, which has slowed adoption. But if you're already in the AWS ecosystem, the cost savings are hard to ignore. Microsoft is rolling out the Azure Maya 100 AI Accelerator, co-designed with OpenAI and optimized specifically for Azure's workloads, and the Azure Cobalt 100 CPU, which is ARM-based for efficiency. Both are expected in early 2026. And here's a bombshell. In September 2025, Intel and NVIDIA formed a partnership to create hybrid systems on chip that combine Intel CPU architecture with NVIDIA's GPU technology. This is aimed at PCs and data centers, expected to launch in 2026 or 2027. AMD sees this as a major threat to their AI PC business and their right to be concerned. The message is clear. NVIDIA's competitors aren't just building better chips, they're building entire ecosystems to challenge NVIDIA's dominance. This chip war isn't just corporate, it's geopolitical. China is racing to build its own AI chip industry to avoid reliance on American technology. Huawei's Ascend chip is their flagship effort, but it's facing serious problems. DeepSeek, a Chinese AI company, delayed their R2 model because of stability and software issues with Ascend chips, and they reverted to NVIDIA for training in August 2025. But China isn't giving up. SMIC, China's leading semiconductor manufacturer, is aiming to produce 50,000 7-nanometer wafers per month by late 2025. And DeepSeek's success with constrained resources shows that software efficiency can partially offset hardware limitations. They're proving that smart algorithms can do more with less. Now let's shift to Edge AI, bringing artificial intelligence to your phone, your car, your smart devices instead of the cloud. Qualcomm is the leader here. Their Snapdragon 8 Elite Gen 5 and X2 Elite chips deliver 80 TOPS, trillions of operations per second of AI power for PCs and mobile devices. Qualcomm has been on an acquisition spree. They bought Arduino, Edge Impulse, and other companies to build a full-stack Edge AI platform. They're betting big that the future of AI isn't just in massive data centers, it's distributed across billions of devices. And then there are the startups trying to disrupt the entire industry. Accelera AI has the Europa chip, delivering 629 TOPS at just 45 watts for edge computing. Next Silicon's Maverick 2 promises 10 times greater performance than GPUs with 60% less power consumption. Tenstorrent, Furiosa AI, and D-Matrix are all developing inference-optimized chips to compete directly with NVIDIA. Celestial AI and IR Labs are building optical interconnect technology, using light instead of electricity to move data inside data centers, which could massively improve efficiency. And Encharge AI is working on analog in-memory computing for ultra-low-power edge AI. These companies are small now, but remember, NVIDIA was once a scrappy startup too. Disruption can come from anywhere. So what does all this mean? Let me give you 5 key takeaways.
First, the workload is shifting from training to inference. Training a model is expensive and happens once. Inference, actually running the model, happens billions of times. That's where the real cost is. This shift favors custom ASICs like AWS Trainium and Google TPU, which are optimized for inference and cost much less. Second, software matters as much as hardware. DeepSeek's struggles with Huawei's Ascend chips show that great hardware means nothing without great software. NVIDIA's CUDA ecosystem is a massive moat that competitors need years to replicate. Third, vendor lock-in is real. Companies like Meta, Microsoft, and Amazon are developing custom chips specifically to reduce reliance on NVIDIA and avoid getting locked into one supplier's pricing. They've seen what happens when one company has 90% market share. Prices go up. Fourth, the price-performance race is heating up. NVIDIA's dominance is being pressured. Analysts expect more distributed market leadership long-term, though NVIDIA will likely maintain dominance in the near term. But the gap is closing. Fifth, Edge AI is the next frontier. Qualcomm, Snapdragon, and others are pushing AI to devices. The future isn't just cloud computing, it's distributed, personalized AI running on your phone, your laptop, your car, everywhere.
Here's the bottom line. The AI chip wars determine which companies control the infrastructure of artificial intelligence, and that affects everything: startup funding, stock valuations, where the next generation of innovation happens. For investors, here's what to watch. NVIDIA is dominant, but facing real competition. Execution matters more than ever. AMD is positioned in both CPUs and GPUs. The Intel-NVIDIA partnership is a threat, but AMD has momentum. Intel, the Intel-NVIDIA alliance could be transformative for their relevance in AI. Microsoft, Amazon, and Google building custom chips reduces NVIDIA dependency and could save them billions. Qualcomm, the edge AI play, is gaining serious traction. 2026 is going to be massive with new product launches and major market shifts. Keep watching this space. If you found this valuable, hit that like button and subscribe for more deep dives into the stocks and trends shaping the future. I'll see you in the next one.